In this video, we're going to do some object interaction. So I have a soccer ball and I have a soccer player right here. And my plan is this. I'm going to have this soccer player move across the screen. And then once their feet get here, I'm going to have the ball suddenly move to be to go into a different position. So I'll have the ball also move. As a result of him kicking it, it'll move across the screen as well. So the first thing I do to get the player to move, I can choose whatever height I want. I'm not going to vary his height in this case, so I'm not going to have a function tied to that. But when I start this at -10 and I play it, the soccer player moves across the screen. But once it gets to where it hits the ball, and that seems to be, it seems to kick the ball right when the slider value is at -5. So I'm going to apply, I want the ball to keep still until that slider gets to -5. So I'm going to use a piecewise defined function like we did in the last video. So from -10 all the way until -5, I'm going to have the x value stay at what it is when it started, which is -3.5. But once I get to a value of -5, I want that soccer ball. I can at least one of them should have an or equal to sign. It doesn't have to be both, but I want that after the -5 slider value happens, all the way until let's say 10, the edge. I want the ball to start moving, so I want it to follow a different rule, and I'm going to have it move twice as fast as a soccer player. Now, if I just play with those values, first thing I have to do though is I have to make it actually move the soccer ball. See how the soccer ball is not moving? I have to put this function f3. I have to replace that into the x coordinate, so f3 of x. And the good news here is that, oops, I forgot my equal sign. So there we go, got the equal sign. Now Desmos knows what I'm trying to do. I have one more mistake here. There we go. I wasn't supposed to put a semicolon. There's supposed to be a colon right there. So now the ball ball's not appearing because, again, remember that in your functions, you don't put x when you're putting them into the coordinate. You put a. So the ball does move once I get it to that point. But notice how these two lines right here aren't connected. What I want to have happen is I don't want this sudden jump. If you slow this down, when he kicks the ball, here at once it gets to -5, when he kicks the ball, there's this sudden jump, and mostly because there's a sudden jump in the break of these graphs right here. So it's suddenly going to change x positions rapidly, which is not what I want it to do. So one way to really easily make sense of it, and make it follow a nice path, is that there shouldn't be a break in your path, which I'm sure that, yeah, I'm going to make that disappear. But you could do some little math. I'll do the math for you to avoid the guess and check, but I'll also show you how to guess and check. So since you don't want a jump in your graph, you want continuity. So the spot where the graphs meet up is -5. So I know that this function, whenever we're starting at -5, its x value when it's -5 outputs a y value, or you could call it a function value, right? Whichever you want to call it. So I want the function value to be -3.5. Well, it's a constant function, so it's always that. So that means this function, I want to have a function right here, this 2x, that when I put -5 into the x, it outputs a value of -3.5. Well, what does this output? This outputs negative, if you do 2 times -5, that outputs a -10. But I don't want it to output a -10. I want it to output a -3.5. Well, there's a lot of ways you could do it. You could multiply it by a constant multiple, or you could subtract it or add it to something. So I'm going to add some kind of vertical shift. I'm going to call that k to represent some constant. I want to figure out what that constant is. Well, it's easy to solve for by doing some simple algebra. I'll just solve for that constant. And so your value of k is going to be equal to, in this case, 7.5. Now, that's doing it the algebraic way. Again, you want to find what value makes these two meet up so that there's not that ugly jump in the graph. So here's how to guess and check it if you don't like doing it that way. You can look at the graph right here. Watch what happens if I shift this up by 1. You see how the gap got smaller? Let me shift it up by 4. You see how the gap's getting smaller? Oh, hey, let me shift it up by 5, 6. Hey, 6 is almost good. 7? Oh, 7's bad. So it's like the gap isn't quite right. And oh, this is exposing that I did some of my arithmetic wrong. Apparently, I don't know how to add 10 to 3.5. That should actually output a value of 6.5. If I were to use a calculator, I would have been able to see that I had a little error there. But if you do calculations right, you can do it the algebraic way. But if you prefer to do it just more of an intuitive way, you can guess and check it. Now, even though this function is like, it's like constant here and then it's like moving, the ball isn't going to actually move along this path because remember, I'm using this to find my x coordinate, not my y coordinate. So what this means is the ball is going to stand still until this point on the slider, and then it's going to start moving at this sort of speed, you could say. So now when I animate that, he kicks the ball and the ball moves forward. So just to play it over in like real time, he's coming across, kicks the ball, and it goes across the sand. In the next video, I'll show you we're going to take this image and build on it, and we're going to enlarge and shrink images and also rotate.